Hey guys, today we're going to take a look at our new packet. We're going to be back in Chapter 1, Introduction to Statistics, Lesson 1.3, Data Collection and Experimental Design. So first we're going to talk about, does SAT prep improve scores? Last year, FHS offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1220, and the average SAT score for all students who did not take the prep class was 1050. So is this situation an observational study or is it an experiment? It's an experiment because we have applied a treatment. We have given something for one group to do and the other group not to do to see what happens. So that's what makes it an experiment. Identify the explanatory and the response variables. Your explanatory variable is your input, so it's the change that you're putting in. So our explanatory variable would be the SAT prep course. And then our response variable is our output. It's what responds to that change. So that would be our SAT scores. Can we conclude that taking the prep course will cause a student's SAT score to increase? Why or why not? No, because there may be other things affecting the scores. So the people that took the SAT prep course volunteered to take the course. So they're probably somebody that is more academically inclined, someone's going to study outside of class. So that could affect how well they did. We call those different causes confounding variables. Okay, so this next one is to identify as many other possible variables, so as many other possible confounding variables that you can explain why the SAT scores are higher for those who took the prep course than those who did not. So just a few would be that someone that took that course might care more about the test and try harder on it. They might be someone that studies outside of class or someone that just takes harder classes during school that may have better prepared them for the SAT. Okay, our next new word is our types of statistical studies. Our first one is an observational study. Researchers observe and measure characteristics of interest of a part of a population. So an example of this would be researchers observed and recorded the mouthing behaviors of non-food objects of children up to 3 years old. So all they did was watch the children, watch how they kind of chewed on toys. They didn't change anything about it. That difference comes in with our experiment. An experiment is when a treatment is applied to a part of a population and responses are observed. Okay, so something has to be changed about the population. So an experiment was performed in which diabetics took cinnamon extract daily, while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease, while the control group experienced no change. Our next type of statistical study is a simulation. A simulation uses a mathematical or physical model to reproduce the conditions of a situation or process. This often involves the use of computers. If you've ever played the game The Sims is an example of a simulation. It's simulating life. Automobile manufacturers use simulations with dummies to study the effect of crashes on humans. So you see those videos of the cars with a little white dummy in there, and it drives forward to a wall and hits it. That's an example of a simulation. And our last one is a survey. A survey is an investigation of one or more characteristics of a population, commonly done by interview, internet, phone, or mail. A survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. So they could conduct this survey by talking one-on-one with the physicians and asking them. They could send out an email. They could send out physical mail. They could call the physicians and ask them. Lots of ways to do surveys. Okay, on this next part, I want you guys to look at the methods of data collection, look at those types of studies, and decide which method for your data collection would be best for 1, 2, 3, and 4. And then pause the video and come back for the answers. Okay, hopefully you got a chance to take a look at those. Here are your answers for 1 and 2, as well as your answers for 3 and 4. The last thing that we're going to take a look at is how you design a statistical study. So there are 6 steps. Our first step is to identify the variable of interest. That's our explanatory variable and the population of the study. So if you were creating an experiment, your variable of interest, like in the one about the diabetic people, you would say that your variable of interest is that cinnamon extract, and your population is people with diabetes. Develop a detailed plan for collecting your data. If you're going to use a sample, make sure that your sample is representative of the population. So if you're talking about the whole school, you can't just choose like one friend group as a sample, because that would not be representative of the whole school. Step 3 is to collect your data. That's your response variables. Then you describe the data using descriptive statistics techniques. So those descriptive statistics are what we learned last unit. There are graphs, are tables that we learned to represent our data. Step 5, interpret the data and make decisions about the population using inferential statistics. And 6, identify any possible errors. This is an important step because once you've identified the errors, you can decide if the errors are big enough that they would really affect your answers and kind of invalidate them.